Our last section on circles deals with the equation of a circle. Now, we've had equations of lines, our y equals mx plus b. We've had equations of parabolas, those are our quadratics. And now we're going to have an equation of a circle. And before I give it to you, let's go ahead and let's just derive this sucker. So in order to derive it, I need to give a point for my center here. Right now I have it at the origin, but let's pretend we didn't know where the center of my circle was. So I'm going to give it a point. And the point that we use in math is HK for the center. So I'm going to put HK is going to represent the center of the circle. Okay? And so let's think about this. I'm going to write an equation for the distance of my radius right here. The distance of my radius. Well, I have the distance formula. So R, the distance of R is going to equal, remember it's the square root, and it's the distance between your x's squared, right? So let's see, distance between my x's. So it's from here to here, right? So I would subtract x minus h. So x minus h, that's the distance between my x values of the radius. So I'm looking at how many units over one in the x direction. And we square that. And then we say plus, and the distance between my y squared, well, y minus k now, right? The distance from the vertical direction, so y minus k, and we square that. Well, we want to make this a little bit cleaner, so we want to get rid of this radical. So for our equation, what we're going to do is we're going to square both sides. That means that cancels that radical. So, and I'm going to flip-flop what I have here. So I'm going to put x minus h squared plus y minus k squared equals, and I'm going to put my r squared on the other side. I just flip-flop it. And there we go. This is what we use for our every equation of a circle right here. Every equation. And if you notice, xy represents some point on the circle, and hk represents the center. So hk would be the center of the circle, xy would be some point on the circle, and of course the r is the radius of the circle. Ugly there. So by using that equation, when I have some information given in that equation, I should be able to know everything on my circle. I should be able to know where the center's at, what the radius is, any point that would work on that circle. Okay, and so if I look at this next slide here, I actually have the standard form of the equation of a circle. So it says the center at HK, and we have it right here. Right? X minus h squared plus y minus k squared equals r squared. And we call this the center radius form. Some people call it the center radius form, the standard form of the equation of a circle. So let's go ahead and see where this comes into play now. So for example, it says write the equation of each circle. And for this first case, it says center at 3, -3, and a radius of 6. Well, let's just write down our equation of the circle right away first. So x minus h squared plus y minus k squared equals r squared. Well, let's plug in information that we know. It says the center is at 3, -3. So I know that 3 is h and -3 is k. And I know the radius r is 6. So I can go ahead and plug those in. So I'm going to plug in 3 for h. So now we have x minus 3 squared plus, well, let's plug in -3 for k. So it's really y minus -3. And minus and negative is really adding a positive. So it's y plus 3 squared equals, well, 6 squared. And let's simplify this. So I got x minus 3 squared. We'll leave that. Y plus 3 squared. We'll leave that. And 36. So there we go. Here's an equation of a circle. And I don't expand out these parts, just because if I would expand it out, I wouldn't be able to tell anything about my circle. But if I gave you this equation of the circle, you should be able to tell that, hey, the center is at 3, -3 by these two spots. And you'd be able to tell that the radius is the square root of 36, which is Okay, because I know 36 is really r squared, because that's the equation of the circle. So that's why we use that equation, because then we can pick out information on it. Yeah, I could also get it on a graph. Well, let me erase what I had right here. So I just want to look at my equation written down. So there's my equation of the circle. Let's start filling out information we know. So x minus, well, do I know the center here? Sure, it's right here, which is at which point? Over 1, up 3, 1, 3. So the x value at the center, which we're represented with h, is 1. So x minus 1 squared plus y minus, this is really my hk, this 1, 3. So y minus 3 squared equals the radius squared, which it gives us, right? The radius is right here, 2. So 2 squared, which I know is 4. So I can just replace that with 4 right away. And there we go. We're done. We got it. Just writing the equation of a circle. Okay, same thing. Write the equation of the circle. Now we're given some different information. It says center at -3, -2. So let's plug that in right away. So I got x minus -3, which is really plus 3, right? Minus and negative is really adding a positive. Squared plus y minus -2, which is plus 2 squared, equals r squared. I don't know the radius yet. Well, it passes through the point 1, -2. Well, I could simply just plug in 1 for x and -2 for y, right? Because that's what it is. This xy is just a point on my circle. So let's go ahead and do that. So 1 plus 3 squared plus -2 plus 2 squared equals r squared. And let's simplify. So 1 plus 3 is 4, and 4 squared is 16. Plus, well, -2 and 2 give me 0. 0 squared is just 0, equals r squared. So 16 equals r squared. Well, to get rid of that square, we take the square root. So r has to be 4. It's really plus or minus 4, but we're not going to have a negative distance. So r is 4, so I know the radius is 4. So all I have to do is go back and plug this into my original equation up here. So we'll replace this with a 4, so 4 squared. So my new equation of the circle would be, well, 4 squared is what? 16. So there we go. There's my equation. X plus 3 squared plus y plus 2 squared equals 16. So basically, I just had to plug in both the center and a point to find the radius now in order to write my equation. And once again, I can do the exact same thing given it on a graph. So let's take a look. Well, do I know the center? Yes, I do. Let's see, this guy's at -2, down 1, 2, 3, 4. So the center is at -2, -4. So the h is -2, the k is -4. So I got x minus -2, which is plus 2 squared, plus y minus -4, which is plus 4 squared, equals, well, the radius is the square root of 17. It lists it right there. So the square root of 17, oh, not 12, square root of 17, and make sure square root of 17 squared. Well, what happens? If I take the square root and square it, the square root and the square just cancel each other. So my equation of the circle is just x plus 2 squared, y plus 4 squared, and 17. And there you go. Well, how about this? What if I gave you the equation of the circle and I told you to state the center and the radius and then graph the equation? Can we do that? Well, sure. Let's state the center. So my original, I'm going to write this out, x minus h squared plus y minus k squared equals r squared. Let's take a look. So here's my h, right? That works out perfect, 2. So I know my center is at 2 something. Well, here should be my k, but if you think about it, it's minus k. So minus what gives me a positive 3? Minus a negative 3 gives me that plus 3. So I know this guy is negative 3. That's how I get that plus sign. So there's my center. I'm going to go ahead and graph that at 2, -3. There we go. So there's my center at HK. And if I think about this, r squared is 4. Right? Because that's the equation of a circle. So what does r have to be? Well, the square root of both sides, r has to be 2. So I know it's got a radius of 2. And I could just really count that off. So if this is my center at this green dot, I can count 1, 2. So there's a point, 1, 2 going up. 1, 2 going left. 1, 2 going down. And really, I should use a compass to get a nice circle. But I'm just going to do the best I can here. So it should look something like that. And there we go. So I stated the center, which is at 2, -3. Stated the radius, which is 2. And I graphed it. Lastly, this is where this gets used in real life. Engineers use circles all the time in the equation of a circle. So strategically located substations are extremely important in the transmission and distribution of a power company's electric supply. Suppose the 3 substations are modeled by the points 3, 6, -1, 0, and 3, -4. Let's be engineers here. So 3, 6, that's D. And then I got -1, 0. That's E. And I got F at 3, -4. There's F. So it makes a triangle. I'm going to actually draw this triangle right here. Straight up and down there. Okay. And it says determine the location of a town equidistant from all 3 substations. Oh boy. So I got a triangle and I'm looking for a point that is equidistant from the vertices. Equidistance from the vertices of a triangle. Well, this goes back to like chapter 4 for us, chapter 5, somewhere in there. There's some lines of a triangle that give us a point that's equidistant, which we call the circumcenter. And the circumcenter is made up of perpendicular bisectors. Perpendicular bisectors. That would give us, if I did a perpendicular bisector from each line of my triangle, I would find a point that is exactly equidistant. Boy, this sounds kind of tough, right? Well, let's think about this. One of these lines, I can find the perpendicular bisector pretty easy. I think about it, I got a vertical line right here. So perpendicular, that would be a horizontal. And the bisector would just be the mid. So I'm finding the midpoint of DF. So basically the average of your x's and the average of your y's. Well, the average of the x's we know is 3. That's pretty easy. And the average of the y's, 6 plus -4 divided by 2 is what? 2 over 2, which is 1. So 3, 1. So that's 3, 1 right there. There's a midpoint. So if I think about this, here's my perpendicular bisector. And if I find one more perpendicular bisector, wherever they intersect at, that would be this spot that's equidistant from each vertice. Well, let's pick another one. Let's grab DE right here. Let's find the midpoint of DE. So D and E, so the average of my x's will be 3 plus -1 divided by 2 and 6 plus 0 divided by 2. So we end up with 2 over 2, which is 1, and 3. So at 1, 3. Oh, there we go. There's my perpendicular bisector. And how do I know the slope of that line that I got to draw? Well, it's got to be perpendicular to what DE is. So the slope of DE is, let's see, it's going up 1, 2, 3, 4, 5, 6, right? 1, 2, 3, 4. So up 6, right 4, which is 3 over 2. So that means the perpendicular slope has to be the opposite reciprocal. So -2/3. So down 2, right 3. So down 2, right 3. 1, 2, 3. Boom, right there. So if you notice, these two lines intersect right at this point right there, at 4, 1. So they intersect at 4, 1. Well, what does that mean? I just found the point that's equidistant from all 3 vertices. So we want to write an equation of a circle with that being the center now. I know there's a lot of work to this guy. So let's go back. I found the point that's equidistant by the perpendicular bisectors. So the center is at 4, 1. So now let's use our equation. So I got x minus 4 squared plus y minus 1 squared equals the radius squared. Well, how do I find this radius now? So this is the tough part, because I want this circle to go through all three of these substations here. Well, let's pick a point that's nice and easy to use. So I know it's got to go through E at negative 1, 0. It's got a 0 in it, that's why I'm picking it. So I can plug in this point into my equation I just came up with. So I can plug in negative 1 for x and 0 for y to solve for my radius. Let's go ahead and do that. So I got negative 1 minus 4 squared plus 0 minus 1 squared equals r squared. Well, negative 1 minus 4 is negative 5. And negative 5 squared is 25. Plus negative, this would be negative 1 squared, which is 1, equals r squared. Well, 26 equals r squared. Do I really need to find the radius, which is just the square root of 26? No, I'm just trying to write the equation. So I'm just going to go ahead and plug that back in for r squared up here. So r squared is 26. Whew. Boy, that took a little bit of work, didn't it? Yeah, that's why engineers are paid the big bucks. It takes some work to think through that. So if I really wanted to draw my circle, it ends up going through all these points right here. This is the tough part. It's something like that. So I know that town has substations that are going to go around, which allows the entire town to get power. That's how that works. Whew, took a lot of work. We got through it. Breathe a little bit. I think you'll be all right.